Okay, now I'm explaining about divisibility rule. Okay, number divisibility rule. So now I'm going to explain about number divisibility rules from 2 to 20 for all numbers. Okay, the divisibility rule for 2 is if last digit is divisible by 2, then that number is divisible by 2. Divisibility for rule for 3 is if sum of digits are divisible by 3, then that number is divisible by 3. Example 369 equal to 3 plus 6 plus 9 equal to 18. 18 is divisible by 3, so 369 is divisible by 3. Divisibility rule for 4 is if last two digits are divisible by 4, then that number is divisible by 4. Example 584. Here 84 is divisible by 4, so 584 is divisible by 4. Divisibility rule for 5. If the last digit is either 5 or 0, then that number is divisible by 5. Divisibility rule for 6. If a number is divisible by 2 and 3, then that number is divisible by 6. Divisibility rule for 7. I will explain about this later because this is a 5 number. It has a special rule. I will explain it later. Divisibility rule for 8. If a number is last 3 digits are divisible by 8, then that number is divisible by 8. For example 5800. Here 800 is divisible by 8, so 5800 is divisible by 8 because 800 is the last 3 digits of 5800. Divisibility rule for 9. If sum of digits are divisible by 9, then that number is divisible by 9. For example 8181. Here sum of digits are divisible by 9. Sum of digits equal to 18. So this number is divisible by 9. Divisibility rule for 10. If last digit is 0, then that is divisible by 10. Divisibility rule for 11. If difference between the digits at sum of digits at odd places and even places is divisible by 11, that number is divisible by 11. Here for example 1331. What are the odd places? Odd places is first digit is 1 and the third digit is 3 minus second digit is 3 plus fourth digit is 1 equal to 4 minus 4, that is equal to 0. 0 is divisible by 11, so 1331 is divisible by 11. So divisible for 12, if a number is divisible by 3 and 4, then that number is divisible by 12. Here I will explain about, here you need to understand about the concept of coprimes. Here. Concept of coprimes. So what are coprimes? Coprimes are pair of numbers, their HCF is 1, then those two numbers are called coprimes. 2 and 3 are coprimes because HCF of 2 and 3 is 1. What is HCF? HCF is highest common factor. Highest common factor. What is highest common factor? What are the factors for 2? Factors for 2 are 1, 2. Factors for 3 are 1, 3. What is the highest common factor? Highest common factor is 1, because common factor is only 1, that is the highest common factor. So highest common factor for 2 and 3 is 1. So 2 and 3 are coprimes. Similarly, if you take the divisibility, let's explain about the divisibility rule for 12. What are the factors? What are the factors for 12? 1, 2, 3, 6, 12. So here, sorry, it has 4 as well. So here 2 and 16 actually gives 12, and 3 and 4 actually gives 12. 1 and 12 actually gives 12. So if a number is divisible by 3 and 4, the total number is divisible by 12. We are not saying if a number is divisible by 2 and 6, then that number is divisible by 12. We are not saying for 2 and 6, because 2 and 6 are not coprimes. You need to choose the factors of a number which are coprimes, then that number is actually divisible by. So if the number is divisible by 3 and 4, then that number is divisible by 12, because here 3 and 4 are coprimes, as well as multiplication of these two coprimes are actually that number. So you have to pick those kind of numbers if you want to find the divisibility rule. So you will understand this later for other numbers. 13 is a prime number. I will explain. It has a formula. I will explain this at the end of this video. It has just for okay. 14 also like a coprime concept. If a number is divisible by 2 and 7, then that number is divisible by 14. 15. If a number is divisible by 3 and 5, then that number is divisible by 15, because 3 and 5 are coprimes. 16. Here 16 is 2 power 4. I will explain here one concept. Here this concept applies for all 2 powers. For all 2 powers. What are 2 powers? 2, 4, 2 cube 8, 2 power 4 16, 2 power 5 32, 2 power 6 64. It applies for everything in this formula. So divisibility rule for 2 is if last one digit is divisible by 2, then that number is divisible by 2. If last 2 digits are divisible by 4, then that number is divisible by 4. If last 3 digits are divisible by 8, then that number is divisible by 8. Here should understand one thing. 2 power 3 is 8, 2 power 2 is 4, 2 power 1 is 2. This is the power. Okay. If last 4 digits are divisible by 16, then that number is divisible by 16. I hope you understand the concept here. Okay, this is the for 2 all power 2 powers. That's why if you see for 4 last 2 digits, for 8 last 3 digits, similarly for 16 last 4 digits. It applies for 64, 32, everything. So similarly we have another concept for all 3 powers. For all 3 powers. If sum of digits are divisible by 3, then that number is divisible by 3. What are 3 powers? 3, 9, 27, 81 and so on. If sum of digits are divisible by 9, then that number is divisible by 9. If sum of digits are divisible by 27, then that number is divisible by 27. It goes on for all 3 powers. So now I will explain. We are done with till 16. For 17 as a formula, because it has 18 is 219 are co-primes. 19 as a formula because it is a prime number. Now I will explain about the divisibility rule for special prime numbers. Whatever I missed in the above list. 7, 13, 17, 19. Okay, divisibility rule for 7. Here just remember minus 2. Here what is minus 2? If a number is you will confirm the number is divisible by 7 only when you have to apply this minus 2. Multiply 2 with the last digit of the total number and subtract that multiplied number with the remaining number. So you have to keep applying that rule. I will take the example and explain to you. Here take the 343 as example. 343 means check what is the last number here. Last digit is 3. How to multiply the last digit with 2. 3 into 2, that is 6. You have to subtract that 6 from the remaining number. Remaining number is 34 because we are removing the 3. After removing 3, you are left with 34. You have to subtract that 34 from 3 into 2, that is 28 is divisible by 7. So you can keep applying that rule until you find the number which is actually divisible by 7 or which are not divisible. For 28, 8 into 2 minus 2, that is 14. You can keep applying if you don't know 7 2s are 14. 4 into 2 minus 1, that is 7. 7 is divisible by 7. So 343 is divisible by 7. So similarly for 13 actually you have to remember plus 4. Plus 4 means let's take 169. The 9 fours are 36. 36 minus 36 plus 16. 36 plus 16 equal to 52. 52. Again keep applying that. 2 into 4 plus 5 equal to 13. So 169 is actually divisible by 13. Actually 169 is 13 into 13. 13 square. So you have to remember plus 4 for divisibility rule of 13. Similarly for 17, so here 17 you have to remember plus 7 minus 5, sorry, so minus 5. So let's take 34. 34 means you have to multiply the last digit with 5. 4 into 5 minus remaining number is 3. 4 5 is 20. 20 minus 3 equal to 17. 17 is divisible by 17. So here minus 5 means you have to multiply the last digit with 5 and keep on subtracting the remaining number. Apply this until you find a number which is divisible by that particular prime number. Okay. Similarly for 19 is actually plus 2. Plus 2 here means let's take 38. 38 means 8 into 2 plus 3. 8 into 2 is 16. 16 plus 3 equal to 19. 19 is divisible by 19. So this is the easy concept. That's all. Thank you. If you have any doubts, comments.